Good morning to one and all. I am Parthiban, working as assistant professor in the Department of ECE, Sri Muthukumar Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called electron devices, which is coming under the category of R2025. The subject code is EC25C01, which is meant for the second year ECE students. The syllabus of this one goes in this way. The unit 1 deals with semiconductor. The unit 2 deals about the PN junction diodes as well as about the special diodes. The unit 3 deals about the bipolar junction transistors and its characteristics. The unit 4 deals with the field effect transistors and its characteristics. The unit 5 deals about the thyristors and its families as well as about the various optoelectron devices. Now we are going to see about the unit 1, which is nothing but the semiconductor, the type of semiconductor and its conductivity, as well as about the electron levels, as well as the energy band structures. Also we are going to see about the carrier concentration, the mass action law, the characteristics and behavior of intrinsic as well as extrinsic semiconductors, the various properties with respect to the semiconductor in terms of temperature, as well as we are going to see about the carrier drift and diffusion current, then current density equation, as well as the carrier lifetime as well as continuity equations. Now we are going to talk about the semiconductor. A semiconductor is a one which is in between the conductor as well as insulator. Basically, the semiconductors are classified based on the atomic structure. The atomic structure refers to the structure of the atom, which is consists of namely three particles. The one is called protons, which is positively charged. The other one is called neutrons, which is neutral in charge. The third one is called electrons, which is negatively charged. The protons and neutrons are present inside the nucleus. The electrons revolve around the nucleus in different energy levels. The atomic number is defined as the number of protons or electrons. The atomic weight is the sum of protons and neutrons. So the behavior of electrons determines the electrical properties of the material. Next, we are going to see about the energy band structure. So there are basically two types of energy bands are there. One is called valence band, the other one is called conduction band. There is a gap that exists between the valence band and conduction band that is called forbidden gap. So the forbidden gap is nothing but the gap that exists between these two. So which plays the crucial role in determining whether the material is of a conductor or a semiconductor or an insulator. So based on this, we can say the materials are classified based on the valence band, free electrons, as well as the forbidden gap. So the valence electrons determines the which is a metal or non-metal, or it is a solid or gas, and the electrical properties of the material based on the outermost free electrons, or it is also called valence electron. So the electrical conductivity of the material can be classified as conductor, insulator or semiconductor. So free electrons are the one which is freely revolving around the nucleus, but it is loosely attached to the nucleus in the outermost orbit. Next, we are going to see about the conductor. A conductor is a material that allows the electric current to flow easily. Conductors generally will have a large number of free electrons. The free electrons move easily when the voltage is applied. Conductors have no forbidden gap. That is a very important point. So there is a overlapping of conduction band and valence band that you can visibly see from the diagram. The typical examples include copper, silver as well as gold. So the materials that is used widely for electrical wiring are called conductors. The next one is we can say insulators. An insulator is a material that does not allow the electric current to flow. Insulators have no free electrons. Their electrons are tightly bound to the atoms. They have large forbidden gap, generally which is greater than or equal to 5 electron volts. The typical examples are the rubber, glass, paper. Insulators are generally used for protection as well as for insulation purpose. Then coming on to the next one, a semiconductor, which lies in between the conductor and insulator. We can say it is neither a good conductor nor a good insulator. There are only a very few free electrons. they have a very small forbidden gap that will be around 1 electron volts, so which will be very small in nature. The examples for semiconductors are silicon, germanium, arsenic, antimony, like that. So there are two ways to make a semiconductor into a conductor. One by means of increasing the number of free electrons or holes, or by means of raising the temperature. These are the two physical phenomena that are available to make a semiconductor into a conductor. Then we can say the classification of solids. From the diagram you can visibly see for insulator the forbidden gap is very wide. For conductors there is no forbidden gap at all. Since the valence band and conduction bar are overlapping with each other, you can see for the semiconductor the electron volts value will be around equal to 1 electron volt. The forbidden gap is very small, which can be bridged or which can be overcome. The valence electrons can be easily pushed into the conduction band to make the semiconductor into a conductor. This can be induced by means of increasing the conductivity levels by means of doping or by means of raising the temperature. But in terms of practical and physical way, we can say by means of adding the impurities or doping, we can increase the valence electrons or free electrons to make a semiconductor into a very good conductor. Coming on to the classification of semiconductors, there are intrinsic semiconductors and extrinsic semiconductors. This is yet another way of classification. So, what is intrinsic semiconductor? It is nothing but a semiconductor in its purest form without any addition of impurities. That is called intrinsic. So, at room temperature, the conductivity will be very minimum, very minimum. So as the temperature increases, the electrons movement will be slowly progressing. So by increasing the temperature, we can make a slight conductivity. This is called intrinsic semiconductor. The extrinsic semiconductor is a one, which is nothing but the semiconductor with the addition of impurities. So the addition increases the conductivity. The range of addition or the addition of impurity concentration increases the conductivity of the extrinsic semiconductor. So based on our need, based on our design, we can increase the conductivity by adding more and more impurities. So by adding impurities, what we are making? We are making a intrinsic semiconductor into a extrinsic semiconductor. This process of adding the impurities is called doping. So the extrinsic semiconductor can be of any type, that is N type or P type. So if you add N type impurities, it will become N type semiconductor. If you add p-type impurity, it will have become a p-type conductor. So the examples you can see for p-type as well as n-type are if you add the impurities like arsenic, antimony. For example, if it is a p-type, then we can say a gallium indium. So these are the various references that I have made for doing the slides. Thank you one and all for hearing my lecture. Once again, I wish to thank all for hearing my lecture. Thank you one and all.